So hello, first time in Finland, really beautiful, nice air quality. It's a little bit different to living near the airport in the UK, so it's great. So speakers, I'm here on my own today. So
By the way, hold the mic really close to your mouth.
Okay, so I will eat the mic, no problem. So I'm Deryng, CWNE, and I work for Untitled, a wireless integrator. Well, not wireless only, but I do wireless. And that's my Twitter handle there. And also normally I speak together with Matt Starling, but unfortunately he cannot be here because he's booked out flat. So we will send him tons of love and kisses, especially for Mr. Matt Starling. Thank you, Lucy. And you can also know us as the Wi-Fi ninjas. So today I'm going to talk about the most exciting thing ever, and I mean it, ever, which is the RTLS, so real-time location services, based on the Mist BLE. And we'll talk about some technicalities and everything that is related to Mist BLE quite shortly and quickly in a hopefully quite interesting way. And this is just the representation of me and hopefully you after the presentation. So every time you speak, talk, listen, hear about the BLE, that's how you should behave. Be excited about it because this is freaking exciting. It's so exciting. I'm about to start jumping now. I won't, but I feel like to. So Mist BLE. Why would you like to use Mist BLE? So I don't understand Finnish too well, but I was using a Google Translator sitting there in the back, so I kind of get the presentation from UC. So he already mentioned asset tracking, indoor wayfinding, so you can find a meeting room, a person, you can find whatever you want really. You can find a toilet if that's your thing. You can use the Mist BLE for marketing purposes, so you can understand where people are located, how they move throughout the building, how they move throughout their retail store. It's a very powerful tool to have to understand how people move throughout the building. And you can also use it for presence and analytics, which is all actually based on Wi-Fi, but it gives you a network-wide stats. How many users are in your building right now? How many of them they are repeated visitors, or how many users they spend more than 1 hour inside your building? So you can do that as well. And who is the BLE for? BLE and RTLS really is for everyone. So you can use it across every vertical. If that's your thing, you can use it at home. So I have RTLS at home and it works great. Wi-Fi versus BLE. So there are two main technologies on the market right now that you can use to have location services, and still the most widely used is Wi-Fi, because every access point that is also serving clients is using Wi-Fi. So people, they just connect to the Wi-Fi and they can be tracked, of course with their consent always. So we always have to ask. Wi-Fi offers a different accuracy levels using different technologies. You can have a cell of origin, so we know that everyone is here in this building, or a trilateration, so we know that you are in the back or in the front. Or you can use some more complicated methods like an angle of arrival, which I'll very briefly talk about. And it's complicated if you want to have good accuracy, and it's complex and quite costly if you want to have good accuracy. So Wi-Fi is challenging. On top of it, if you want to have a client-based applications on your mobile phones, it's challenging for the phone and for the application too, because battery heavy and the application has no way of knowing which phone it's running on. It's no way of knowing the MAC address of the phone that it's running on. So it poses some challenges. And then we have the BLE. So Mist is using BLE, and Mist is using BLE for a very good reason. Potentially BLE is more accurate than Wi-Fi, but it depends on how it's implemented. So BLE versus VBLE, what is the difference? So Mist is using a concept called the VBLE. I will tell you how it's different to the BLE. So BLE is normally, BLE is a technology, so that's a name of Bluetooth Low Energy. So it's a 2.4 gigahertz technology. Low energy, doesn't travel too far because the transmit power levels, they are really low. And normally you would have a beacons dotted around the premise, and it's based on proximity. So you get close to the beacon can, this close proximity to the beacon can trigger an action. It can, in your mobile phone, put you a notification or open a website or whatever you have defined in the application, but it's based on proximity. And now with Mist, instead of using the battery-operated beacons dotted around the building where you have to change the batteries every year or two, you actually put this BLE into the access points, and I will talk about it in more detail in a sec, how it really works, but it's really cool. You don't have to maintain this infrastructure of beacons anymore. All you need is like a client serving Wi-Fi access points that have the BLE functionality built in. And it will give us quite a great accuracy, as you will see in a second. So is BLE transmitting or receiving data? And that depends. So traditionally, BLE beacons, as the name suggests, so the beacons battery operated, they will transmit the data, and then the infrastructure would track, this data. So let's say I have a beacon and I have a mobile phone, and my mobile phone is listening to the BLE beacons. So I get close to the beacon, I hear it strongly, so my phone knows that I'm close to it. So normally my phone would listen to the beacons would transmit. With Mist, however, you can do it both ways. So Mist access points, they can either transmit or listen to the BLE data. And I will show you how is it useful in a sec. So long story short, BLE gives us amazing accuracy, low complexity, lower cost than Wi-Fi, and it's pretty much easy peasy, lemon squeezy. So that's BLE for us. How does it work? So BLE, built into Mist access points, it normally, to have the most accuracy, you would have a client, mobile client, running an application that would be listening to the beams transmitted from the Mist access points. And then each access point has a directional antenna arrays around the access point that creates 8 different beams in 8 different directions. And if you have multiple access points that your clients are listening to, you will listen to, from 2 access points, you will listen to 16 beams. And then your mobile phone will send this data back to the cloud will do the calculation, and it will send the location back to the client. And it's very accurate and it's very fast. You can also a little bit shift it over, so your phone, and every phone on the market today, like most of the phones on the market today, they have BLE functionality built in, where they can be tracked as assets even without the application. It won't be as fast, it won't be as accurate, but it will also still work. And this is the inside of the Mist access point and the multiple antenna array that creates this 8 beautiful beams. It's actually very, very interesting that they packed so many nice features into such a beautiful small access point. And this is very mind-blowing feature. Try to imagine like how you used to deploy the RTLS system in the past. Is you would come in, you would put a lot of infrastructure around, and then you would have to calibrate this infrastructure manually. So you would have to go somewhere, click, I'm here, go somewhere, click, I'm here, and then infrastructure will calibrate itself by you clicking where you are. And there is another approach where you can use like a one profile that is used by all the clients in the building. And of course, as we know, all the clients, they have different antennas built in. They have different sensitivity of the radios. So it's not like all the clients, they are very similar, and therefore with just like a one profile we cannot ensure good accuracy while tracking those clients. And with Mist we're using machine learning to profile every client that is moving around the building, and all it takes is just to go to the building and move around, and we will be profiled. So that's called like the probability surfaces from Mist using the BLE and the VBLE. And this is how the Mist infrastructure sees our clients, and it's actually very, very mind-blowing. So you can see, does this work? It works. So you can see like every access point has like 8 different RSSI values, and this is what the client is sending back to the cloud. So this client is seeing all of those beams with these RSSIs, and based on that, the system will roughly know where the client is with a higher probability. So one area is more probable than another, and that's how system like thinks where the client is. This is how it looks. It's a little bit fast forward, but with all these access points, they can actually, the more access points you have, the more accurate it will be. And also we are using like sensors built into the clients, like a compass or accelerometer, so it gives us even more accuracy. Okay, let's move to the RTLS functionality. So with RTLS we can use something called like a presence and analytics. This typically relies on Wi-Fi, and it gives us this network-wide stats. and there is no need for the careful RTLS design. However, if you want to know exactly where users are in the building, we are relying on either Wi-Fi or BLE or ultra-wideband or anything else. It can be like even GPS or mobile, and this requires a very careful RTLS design. And this will be different for MIST, this will be different for Cisco, but long story short, you'll require a little bit of more infrastructure to have accurate location tracking. And actually we can use presence analytics and location to engage with clients, to specify what happens when the clients are where they are. If you have, like, just an example, if you have a returning customer that comes over at 12 o'clock around the scene here, we will give him a free banana, you know, because we know that he's like a customer that returned to us, so we'll reward him with a free banana. And we wouldn't have been able to give him this banana if we didn't know that he's a returning customer standing close to the scene. And a few of RTLS design tips for MIST. So first of all, if you are thinking about designing for MIST RTLS, you would mount access points horizontally, facing down, and you would know the LAD orientation. This is very important because if you orient the access point wrongly in the azimuth plane, it will not work too well. Tip number 2, do not mount access points too high. So between 2.5 and 4.5 meters is perfect. If you mount them higher up, it will still work, but it will lose its directionality, so it won't be as accurate anymore. Number 3, cover transition areas. I will show it to you in a sec in an example what I mean by transition areas. So it's like a tunnels. And 4, ensure that the line of sight is maintained between access points and clients. So as Peter has mentioned in his presentation, putting access points behind the ceiling tiles is a big no-no, so you have to be careful about how you mount those beautiful access points. And then you would keep a distance between a piece, between like 8 to 15 meters normally. You can slightly relax it when you have like a long corridors where, you know, the propagation, it bounces like off the walls. You can have like every 20 meters an access point would still work perfectly. And number 6, the distance requirements can be slightly, so I just covered it. MIST RTLS design. So you can see several dots here. And the blue dots, this is actually from the MIST training session, which is very good. It's available on the MIST dashboard if you are after more BLE details. Like blue dots, these are the standard access points locations which you would put for capacity and coverage. So this will give us like a coverage throughout the entire floor. Everyone will be happy and connected to the Wi-Fi network. But now if you want to introduce more RTLS functionality to the network, we would start adding more access points. And the black dots, these are the additional access points. So we would want to, let's say now, if the users are in the meeting room, we would want to be able to capture when the users are moving down the tunnel, the corridor. So these are like the passage areas. We have another passage areas like here that they are moving through, I don't know, it's like a small meeting area with no walls, but we also want to know when people they are moving there. And the big advantage of MIST is that we can put standard Wi-Fi client serving access points with built-in BLE where we need to cater for Wi-Fi clients, and then we can use something that is called the BT11s. These are like a smaller, cheaper, very cheerful, beautiful access points that only have BLE arrays built in, just to give us more RTLS accuracy. And these are just few examples from a real MIST deployments. So MIST is really a perfect fit for bigger events when you have thousands of people moving around. It works brilliantly, but it also requires, like, you know, to stick to our design tips. So you can see that the access points, they are dotted around in a quite dense fashion, but it's not too bad because with BT11s you can you know, have quite a lot of these access points without having to put this massive big Wi-Fi APs everywhere. And components. So Wi-Fi based RTLS. If you want to make Wi-Fi accurate, what do we need? We need to have antenna. Actually, we need to have more antennas. We need to have a lot of antennas built into the access point, and these access points are really massive. Has anyone seen like a big access point from the competition, like with angle of arrival, maybe from Cisco 4800 series access points? So they can be quite big. They will work very nice, but they are big. And also you need to have a wireless LAN controller or redundant wireless LAN controllers. You need to have map services server where you put the height and azimuth of the access points. Then you need to have the redundant data crunching servers, so all the access points that will be talking back to the infrastructure. And finally, you need to have a cloud front end to view this data, where the users are, and see these beautiful graphs. And if you want to add even more accuracy, you can still use the battery-operated beacons. And this is difficult and expensive and time-consuming. Now, what do we need for Mist BLE to work? We need Mist access points, and we need Mist dashboard, and that's really it. We don't need anything else for it to work. No servers, no local data crunching boxes, nothing else. That's all we need. And did I mention daisy chaining? That's a great feature. Try to imagine having this big conference and that you have to put a cable to every BT11 or AP41 or AP43. It will take a lot of switch ports, it will take a lot of cabling. You can daisy chain up to 4 BT11s out of a single PoE port, which is super nice and easy. And the BLE arrays are built into the every access point, and that includes the outdoor access points, even with external antennas. And it's another amazing feature. Like, try to imagine having like warehouses where you have a requirement to cover the outside, but not like entire parking lot. Maybe just just the outside where you have some transport coming in. You will still be able to use external APs without any additional equipment, and the BLE tracking will still work perfectly. A very quick demo. So this is our demo environment. That's my house, open space, 7 by 9 meters. We had just 3 Mist access points there, around 2 meters high, 2.2 actually, azimuth to 270, and we have Matt, a very good looking model walking around my house. This is where you set it up. So we've uploaded the plan of my house to the Mist dashboard, and you can set the scale. You can set wayfinding paths. So let's say if I know that I will only be walking around here and never cross through the room, I will put the wayfinding paths around the room only, because I know that I have furniture in the central part of the room, so I will never walk there. If I put wayfinding paths around, I will be snapped to this wayfinding path, making sure that my location is more accurate, is presented more accurately than it really is in the real world. And that's how it looked like. So, on the left hand side you can see Matt holding a phone which is on the central side. So this is from the application. This is like a Mist experience application, and you can see 2 zones. This is a kitchen zone, this is a living room zone, and we can see that Matt is in the kitchen zone, and he's getting close to the orange circle. And the orange circle is the first VBLE alert, which opens a website. Since he's... what happened? Oh no. Sorry guys. Let's watch it again. So I won't be clicking anymore because I clicked the cursor and it stopped it. So we have Matt walking around, and you can see that he's walking around the blue path, which is a wayfinding path, because we knew that he would be walking around only around of the premise. Now he's getting close to the orange circle, which is the VBLE alert opening the website, how to brew a coffee because he's close to the kitchen, and then he will be continuing his way around the house. At some point getting close to another VBLE alert, opening a very nice website, good resources for Wi-Fi, podcasts and blogs. And what I want to point here is that you can see his compass from the phone. The accuracy is quite amazing. It's like up to 1 meter, and the frequency of calculating his location is sub-second, which if you animate this dot, it feels like a Google Maps inside. So it was really, really amazing. And thank you very much, Mist, for providing us with the access points, and we would be delighted to do some more tests like that in the future. And lastly, just to compare VBLE to different technologies available on the market. This is the last slide, so it won't take too long. We have like a trilateration, which is a standard RTLS solution which doesn't require any specialized equipment. You can use just omnidirectional access points to have a trilaterated signal to have like accuracy between 5 to 7 meters. That's a marketed accuracy. In the real world, it's about 7 to 10 meters. Peter would argue, he said that he's seen like 1 meter accuracy, but it's stretching it. And also the location computation frequency can be around 15 seconds, which is quite slow. It's enough for the marketing team to understand where the people are, but it's not enough for Bluetooth experience, for wayfinding indoor. Then you have Cisco Wi-Fi, angle of arrival, hyperlocation is actually very, very accurate, but it's very complex at the same time. And the real accuracy is around 1 to 5 meters. And the location computation frequency is between 2 and 5 seconds, so it's still probably good enough for the indoor location wayfinding, but what distance can you walk within 5 seconds or within 2 seconds? It's quite long, so it won't be as accurate, however it works. And with MIST BLE we have around 1 meter accuracy, sometimes less than 1, but very infrequently, and you always, doesn't matter what the condition is, if you have the application running, you will have sub-second location calculation frequency, which is mind-blasting. So thank you very much, tons of love. If you have any questions, feel free to ask. I'll be around, so happy to answer anything. Thank you.